I don't know, it's honestly a privilege to get an opportunity to talk to a bunch of smart, interesting people. And what I love about Club is this sort of like shared body of things that we've experienced and read together. So I feel like I'm speaking from that place. And it's rare, you know, I do presentations in lots of contexts, but it's rare for me to just try to be like, you know what, I'm going to try to, in this case, think about and articulate my metaphysics, which I think is a good exercise that everyone should do. And I'd love to hear more people talk about their metaphysics, because I think it's sort of the place from which often a lot of the work that I do ends up coming, whether I make it explicit or not, or whether I even know it in myself or not. And further, by trying to articulate it, I think it changes what it is. And I think the actions and the things I do in the world also inform my metaphysics. So I think it's a compelling project. And so this is an attempt to do that. So this presentation is change of basis. So right out of the gate, so my dominant ways of knowing tend to be visual and computational. And so this is going to be kind of in that spirit. And so if you are much more like of a linguistic processor, it may be a little confusing why for me this is what it is to know something, but really concepts, when I can finally like visualize them in some way, or if I can imagine writing a program that enacts certain aspects of them, that's a very profound way of knowing for me. And so that's going to be an aspect of what comes up here. Now that's related to my work in so much like how Kenny opened, you know, cards on the table, working in competition law. You know, I work quite a bit in machine learning and machine perception, and so this informs a lot of how I think about perception. I want to emphasize I don't think that machine perception is the same as human perception, but I think drawing analogy between the two lets me think about perception and the experience of the world in compelling ways. Okay, so you're going to get a 2-slide intro to machine learning, because I think that's going to be a useful grounding for the rest of the presentation. So, and this is emphasizing a particular kind of machine learning called classification. The idea essentially is that you create a data set by measuring things that you care about, say photographing. So here I'm photographing this snail, turning that into a measurement. So I get a whole bunch of like numbers that describe the brightness of various points in the image of this snail. Then I go through and I take this big set of photographs of snails and other things that I have, and I label them. I say, okay, this one's a slug. Oh, I wrote slug, but it's actually a snail. But this one's a slug, so this is mislabeled. This one's a jalapeno, etc. You know, I take a photo of a bunch of stuff that I care about and do these labels. Then I show this labeled data set to my computer. Here it is reading a book, and quote unquote, have it learn. Obviously, there are a lot of details missing there, but the big picture of it is essentially this, that you try to show this data set to your computer and have it learn the patterns that make this set of numbers correspond to slug and this set of numbers correspond to jalapeno. Okay, so what is this actual learning process? So, I mean, it's a mathematical process that's happening, but as I said, my bias tends to be towards understanding things visually and in fact spatially. And so there's an interpretation of what's going on inside of a neural network, which is the particular kind of machine learning that I tend to do, which is spatial. And I'll just try to give you a brief intro to this. For some people, I think these kinds of ideas are very intuitive. For others, it's a little bit of a weird way to think about stuff. The starting point is, you may agree that a point in 3D space can be given by a list of 3 numbers. You know, I can tell you where you are on the Earth by giving the latitude, the longitude, and the altitude, right? Those 3 numbers will kind of tell me where you are. You know, I could tell you where you are in your house. I could say that corner is 0, 0, 0, and that corner is 1, 1, 1, and then that gives me a coordinate system for the whole room. This is a big chunk of what you'll have done maybe in high school mathematics. If you're plotting the position of something over time, you might measure it by a series of numbers. So this is basically what dimensionality is. It's the number of numbers it takes to describe the point of something, the position of something. Okay, so in the last slide, I said, okay, well, in machine learning, we're going to measure things that we care about. Maybe those are slugs. And that measurement will itself be a list of numbers. That list of numbers might be the brightness of each of the pixels in the image, right? So I can represent an image as this pixel is this bright, this pixel is this bright, this pixel is this bright, long list of numbers. So that long list of numbers, in the same way as it can in 3D, can be understood as a point in a thousands of dimensional space. So when I tend to think about what a photograph is, for instance, a photograph is a single point in a very high dimensional space. And a very similar photograph that maybe is different in just 1 pixel is just a point that's nearby in that space. And a very different photograph might be a point that's very far away. So this is kind of a core, just like sort of way of seeing the world, which is very natural for me and tends to inform a lot of the work that I do. Okay, so effectively, what a neural network is doing, you've probably seen these kinds of diagrams before that like something goes into the side here and it goes through a bunch of complicated looking layers of processing, one after another. And then out the end pops out either the number, the answer is slug, or the answer jalapeno, or maybe something else if there's other categories you might care about. What you can understand each of these layers as doing is effectively taking, remember I said that the input could be thought of as a point in a high dimensional space. Each one of these layers is doing a warping and a stretching of that space. Each one does a little bit of a warp, and each subsequent one does more and more warping, until on the output, the things that you care about, maybe all of these red dots were labeled jalapenos, and all of these blue dots were labeled as slugs. You stretch the space until those two classes are separated. And you just draw a line right between them and say everything on this side of the line is a jalapeno, and everything on this side of the line is a slug. Like that's what, I mean, obviously there's other kinds of machine learning and there's like some more complexity to it, but to a pretty good approximation, this is what machine learning is doing. Okay. So one of the things that I think can be helpful when you actually understand what's happening in the network, as opposed to just saying, I don't know what this thing is doing. You show it slugs and jalapenos and it tells you if there's slugs and jalapenos, is that, and I'm going to try to justify this in some of the coming slides, there's no such thing as an unbiased algorithm. That's not a meaningful concept to like appeal to. If somebody's saying we're going to try to generate unbiased, algorithms that are going to go out there into the world and be true and faithful to reality, that's not a thing. And in fact, I'd go further, and I think luckily Club would probably all agree, there's no such thing as an unbiased perception. I think these are like flip sides of the same conceptual coin. So what are some reasons why that might be? Well, so here, these are two of the steps on the left here that I just described as the steps of machine learning. And there's many places here where we construct reality. So we create a data set by measuring. Okay, so first of all, how and what do I measure? How do I represent it? Am I taking photographs with a camera? Does that camera only capture light in the visible light spectrum? Or does it capture light into the ultraviolet or the infrared like a bird might see? Why am I taking a photograph and not, say, a 3D scan? Why am I taking one photograph and not maybe several? So there's a choice here in what exactly it is that I'm measuring. And this is analogous, I think, to different beings in the world having different sensory apparatuses. So I think the world as I experience it with my eyes and ears is very different from the world as, say, a spider would experience it with its 8 eyes. Okay, second of all, so you're creating a data set by measuring things that you care about. So first of all, what is a thing, right? In particular, like here I took a picture of a slug, but maybe my data set, and it's things that I care about, maybe my data set doesn't include every random pocket photograph that my phone could take. If I put my phone in my pocket and it's just taking photos, most of them are going to look like the inside of my jeans. Those are parts of the universe. I could decide to make my data set all the interior of my pocket, but most likely I'm not going to be doing that. So out of all the infinite sets of photographs of the world, even in the photography domain that you could take, you're making a selection to take a set that you do care about. And that's a choice. That there is no right answer there. And then you label your set of measurements with what they are. And so there's a big question, well, what are the categories? What are the kinds of things that there can be? Why is this particular collection of atoms a slug? And what goes in each category? So maybe once I've defined the slug category, I have to decide what goes in it. So I want to emphasize, I don't think any of these questions have objective answers. So right away, Cheryl likes to use the term groundless ground. You're not starting from a place of objectivity in human perception and machine perception, and that's not a thing you can or should aspire to. You could aspire to like a just algorithm, perhaps, and there could be a certain kind of bias that you think is unjust that you want to remove from your algorithm, but there is no objectivity here. I'm going to focus in particular on these what are the categories and what goes in each one questions, because I think they're interesting, but all of these questions are meaningful. Okay, so what are the categories? I mean, again, this group is probably more comfortable than a lot of groups in understanding the constructedness of categories, right? So like in our lifetimes, Pluto went from being a planet into being some dumb rock. Nothing else changed. A human body got together, a bunch of human bodies got together, and they just decided, we've changed our mind about what a planet is. And now Pluto is in this category. Previously, it was in that one. Plato's got this concept of carving nature at its joints. In some sense, this is what all classification is doing. And I think the question, even the statement at its joints, kind of suggests an objectivity. I think there are more or less natural, and we get into what that means, ways in which you might divide up reality, but there isn't, it's not God-given. The lines that you draw here, this you could think of as the output of a neural network, like I showed before, and we've chosen to draw a cut in that space and say everything on this side is a planet and everything on this side is a dumb rock, right? That's, again, a choice. I think this point was made abundantly clear in a Borges essay in which he described a classification system for animals in which these were the classes of animals. And I'll just read some of them aloud. It's A, belonging to the emperor, embalmed, tame, suckling pigs, sirens, fabulous, stray dogs, included in the present classification, frenzied, innumerable, drawn with a very fine camel hair brush, etc., having just broken the water pitcher, and that from a long way off look like flies.
Yeah.
Yeah, I love this, right? This is a set of categories. I could put animals into these categories if I wanted to, and I wouldn't be wrong. I might not want to do that, but I could. And in fact, there's a nice connection to machine learning. A South Korean machine learning arts duo did an art project in 2018, Animal Classifier, where they trained a convolutional neural network on these categories. They got people on Amazon Mechanical Turk, which is the same labeling system that we label in all the other classification systems when we train neural networks. And they built the system, and you can feed images into it. And they had this beautiful demonstration of it under bell jars, and these screens would show animals from these different categories. And so here is something classified as innumerable. Although when I look at this picture, I think it also from a long way off looks like flies. So I'm not sure if I agree with this classification, but regardless. Okay, so that's one example of like sort of this arbitrariness of the choice of classifications. One thing that I think is compelling, if we allow it to, though, is that the internal spatial representation of our neural network suggests, if we allow it to, that the borders could be elsewhere. So I think that there's a real possibility, especially in this moment when machine learning is new and we're still questioning it, and we still see it. It's not just something that our parents handed us when we were born. It's a new thing. And if we understand the spatiality of its internal representation, then I think we can ask the questions, well, hold on, why did I draw the border here? Should I have maybe drawn it here? I think this is a rare moment. And I think that it's not that it will necessarily go this way, but I think the potential is there. In particular, I think the spatial representation, I can look to other fields, and I think particularly about critical geography as a field that really understands the constructedness of, say, the nation state, and thinks a lot about how we draw boundaries in space. And I think that those same sorts of ideas can apply when we think about how to draw boundaries in semantic space. And so this is a quote from David Harvey. How we represent space and time in theory matters because it affects how we and others interpret and then act with respect to the world. So this is actually also another reason why I think it's interesting to try to articulate my metaphysics, is I think by understanding the stance from which I model what are things in the world in my brain, I think by making that explicit, it makes it negotiable and makes it changeable, which I think is interesting. Okay, so these boundaries are constructed, but they're also not, right? So I can take the border between USA and Mexico, which may have originally been a very conceptual thing without much material grounding, right? You know, it's a political process between a bunch of people and warfare and various things. And sometimes borders line up with like natural features like mountain ridges and rivers. Sometimes they don't. But over time, it accumulates. So as we believe this particular boundary more and more, it starts to take on more and more material form. So this is Mexico, this is Tijuana on one side, and this is, I don't know, whatever's on the other side of Tijuana. And I want to emphasize that now, even if I think this boundary is constructed, there's a whole lot of material constraints that make it challenging to remove this boundary. So for instance, there's different standards about who gets to use what wireless spectrum on this side of the boundary and on this side of the boundary. So it's very hard to have your cell phone handle these two different sides of this line properly. If there were train tracks on this side of the line and train tracks on this side under different regulatory regimes, they may not be compatible. So you might not be able to move goods from this side of space to that side of space, a truly conceptual boundary made material. So I think there's a very important politics to where these boundaries are and to recognizing that they're constructed and yet they're material. So yeah, so classifiers construct the classes they seek to separate, and through their repeated application, they give them material form. So machine learning is not a separate process observing reality, but it's a creative process participating in the construction of reality. This is true of all perception. I think machine learning is particularly interesting, because it's just what I work with, so I think about it a lot. But it's scalable in an interesting way. You know, I may have my particular delineation of what I think is the USA and Mexico, but I kind of need a whole bunch of other people to agree with it for it to take on this material form. If I can get a whole bunch of people to like download my software or use my classifier that distinguishes between things, there's a leverage to that. Again, for better or for worse, it's an intervention point that holds a lot of power over these classifications. I think this is related to the Adrienne Marie Brown quote, which I love: what you pay attention to grows, right? So what I attend to, the classes that I choose to believe exist, start to exist more and more, the more and more I believe in them for these sorts of reasons. So some of you may recognize this from the Folia de 2020 streetwear collection. This is a visual representation of the metaphysics, basically, and it's sort of co-developed with me and Cheryl, but I think we both interpret it in somewhat different ways. This is our shared intersection point, that we kind of agree that this picture is the metaphysics. We just may have differences on what exactly this picture means. To me, these dots in the image, in some sense, represent underlying reality, but they're not accessible to us. We never actually engage with these dots, and my choice to draw them as dots is itself a construction. But there's an infinity of different ways that we can divide up these dots. So that neural network can delineate the space of its inputs in an infinite space of different ways. And in fact, it can measure its input in an infinite set of different ways. So I think each one of these different configurations is a different way of seeing. It's a different way to divide up the world. And each one has its own emergent patterns govern the relationship between elements of each category. I believe we have trouble holding these different ways of seeing simultaneously. Much like this Necker cube, which I can see as coming out of the page or into the page, I do think there is a skill to sit shifting between them. And again, I think one of the things that I like about Club Club and what I see as a theme in the people here is this constant desire to challenge the way we've drawn these lines and consider how we might have drawn them otherwise. Again, with connection to machine learning, I think a given neural network instantiates one way of seeing, and in so doing gives it strength. So I think all of these are unfolding simultaneously. If you attend too much to one, you'll be caught off guard by effects revealed by another. If you focus just on the economic lens, you'll miss something that's happening over here on the spiritual lens. I think there's a strong connection here to lots of things, but we've been thinking about evolution recently. I think selection as a process is simultaneously occurring at the individual scale, at the community scale, at the mimetic scale, and in symbiotic points of view, to name a few. If you focus on just the individual, you'll be caught off guard by some selection process that's happening at the community scale. If you focus just on the community scale, you will miss its manifold intersecting identities. So this is also how I understand intersectionality, as these different constantly overlapping systems of classification that are in relationship while also being mutually contradictory. So this raises the question for me: what ways of seeing might I cultivate in myself and in my algorithms? I think that these ways of seeing are socially constructed. So here we stand together and we chant and we say, I believe this is the USA, I believe this is Mexico. And that starts to give form to these lines around the dots. And that's great and that's important. And I don't mean to say that I should be this great individual, but I'm really interested in which are the dots, the circles around the dots that are just forming. If we're all distracted and focusing on this one, what in fact should we be paying attention to over here? Now this picture is slightly wrong, because I'm not actually doing this alone. I'm often doing it with you guys or with Cheryl. I'm just trying not to do it with the bulk of the world. And further, I'm doing it in relationship with many non-human actors. So this is Biggie Leaves from the original Club Club. This river, these guys are also talking to this chair and this bird. And this is very important, right? We don't have total control as human individuals over how we draw these lines. They're in negotiation with all of these different agental forces. And this is a neural network that I'm training here. And this is actually a key point, right? That I can also further reinforce the lines I'm drawing by constructing different systems that replicate that way of seeing. Okay, I'm running out of time, but I do want to get to this, and it relates to Kenny's stuff. In particular, I think one way of seeing that is maybe underemphasized by our culture, and one that's very hard for me to think in, so therefore I'm very interested in, is the privileging of scale and spatial locality. We tend to think of causality as moving upwards from small things to big things, that there's tiny weird quantum stuff, and that makes up atoms, and those make up molecules, and those make up cells, and those make up individuals, and those make up families, and those make up communities. And this stuff is more fundamental and smaller. Fundamental physics is all about knowing about what's the smallest thing that everything is made of. And this stuff is all caused by stuff happening at this lower level. Big stuff is made out of lots of little stuff. I think an analogy to sound can show how those can be totally different ways of looking at things. So if I'm looking at someone playing a saxophone, this could be the waveform of the pressure coming out of the saxophone. That's what you're used to seeing as a sound wave. I could represent that as a series of little samples, of tiny little blips. At this moment in time, this was how much pressure there was. At this moment of time, this was how much pressure there was, and so on. That's a perfectly reasonable representation of the signal. That's what a microphone picks up. That's what a CD might represent. I can also equivalently represent the exact same signal as a summation of a whole bunch of frequencies that are infinite in space, but only at a fixed spatial frequency. That's actually closer to what our ear physically hears. Our ear never measures these samples. Our ear measures combinations of frequencies. But the exact same thing can be represented in both of these ways. Neither one of these is more fundamental, even though this one is smaller. Yeah, so just repeating what I just said. So I think this is a really interesting example of what's called a change of basis, where you can imagine samples on one end and frequency on the other and rotating it around and understanding the causality is going either way. The small things can be caused by the big things, or the big things can be caused by the small things. Now, this kind of thinking is quite commonplace, and I think it's very fruitful for me in my engineering work to be constantly trying to shift between these bases, these ways of seeing. In my research, I'm in particular studying fractal bases, where the objects have complexity in both space and scale. So they look kind of more like these sorts of things. I'm trying to understand if these become the base objects from which we build our ontology, what kinds of new phenomena can we see in the world? And how might the subversion of the scale hierarchy reveal the world anew? How might I understand atoms as being constitutive of cells and not the other way around? How might I understand the opioid crisis as being constitutive of groups and not the individuals creating the crisis? How might I be able to swap back and forth between these ways of seeing, spin around this Ferris wheel? Okay, so this is great in theory. For me, a major challenge is my phenomenological experience of self. So I've convinced myself in theory that the self is just one circle drawn around these dots, and it could be drawn otherwise. I understand that I'm thinking in relation with you, in my culture and history. I understand that I started baking sourdough at the beginning of COVID because a cultural wave was passing through me. I wasn't as an individual making that choice. I feel like all these feelings of connection, but vividly my experience of self ends at my skin. And this is a big problem. I've got a strong intellectual understanding of this idea of the privileging of scale as being not necessary, and yet I bound myself into this particular scale-bounded body. So a question I have is, what might the Fourier transform of the self look like? Not just like we are all one, but a specific new circle. How could I otherwise draw my boundaries of self and change that basis of the representation of reality? Right now, I understand it maybe as the spatially localized point in time, but just as the Fourier transform shows us, there's an equivalent representation where I am this wave held across all of these people in society. What would it be possible? What might it mean for me to understand the world in this way? Again, experientially. I kind of am there conceptually, but how do I get there in my body? Yeah, what would it feel like? Okay, that's basically it. These are the questions I'm thinking about. I think a note of caution that I do want to end with is, as much as I'm fascinated by this process of drawing circles around the dots and how those circles could be otherwise, each one of those is itself an illusion. And so I love this from the Tao Te Ching, that the 5 colors will blind a man's sight, the 5 sounds will deaden a man's hearing, and the 5 tastes will spoil a man's palate. Like, all of your classification systems are in some sense separating you from the thing itself. And so I'm trying to remind myself to understand each one as tentative, constructed, and fundamentally empty. And that's it. So this was my metaphysics. Maybe this one is yours. You're various people that have influenced me along this journey.